Okay, what if you could run 100 complex research experiments while you sleep? And what if it cost you less than a movie ticket? I'm not talking about some massive supercomputer. I'm talking about a tiny 630-line Python script from Andrej Karpathy called AutoResearch. And honestly, it's completely changing what it even means to be a researcher.
This right here, this is the core idea. Forever, the pace of scientific discovery has been limited by us, the human researchers, the, meat computers who need to eat and sleep and painstakingly write down every single little change. So AutoResearch asks a really simple question. What if we could just take that human bottleneck out of the loop?
So let's be clear. This is not about replacing humans. Not at all. It's about a huge shift in our role, right? Moving us from the tedious, hands-on work of running experiments to the high-level strategy of designing the system that runs them for us. You become the director, not the actor.
All right, so to really get why the solution is so brilliant, we first have to appreciate the problem it's solving. I'm talking about the slow, painful process of trial and error that, let's face it, defines so much of scientific work.
This is the engine, the heart of AutoResearch. It's a really simple automated loop. An AI agent gets a goal, it comes up with an idea, it tests it, it checks the results, and then it decides. Does it keep the change or does it throw it away? And then it just does it again and again and again, endlessly.
And the crazy part? It's how simple it is. We're not talking about some massive, complicated piece of software. It's this small, self-contained little script that basically gives an AI a sandbox to play in, and a super simple goal. Just make this one number better. That's it.
Now, you're probably wondering, how do you actually do this without the AI just going completely off the rails and breaking everything? Well, the whole system is built on this really clever architecture Karpathy designed, and it works kind of like a contract between you, the human director, and the AI agent.
This separation of powers is just genius. The whole system's integrity, its trustworthiness, it all comes down to 3 separate files. And each one has a very specific, unchangeable job. So let's break down this contract.
First up, you've got prepare.py. Think of this file as the immutable judge. It sets up the test, and it defines the one single score that matters. In this case, it's a metric called validation bits per byte. This file is totally locked down. It never, ever changes. That way, you know every single experiment is being graded against the exact same totally fair yardstick.
Next, there's train.py. This is the experimental canvas. This is the playground. It's the one and only file the AI is allowed to touch. It can tweak the model, mess with the settings, change the optimizer. And it just patiently tests one small idea at a time, piling up these tiny little wins that a human researcher, with our limited patience, we might find it just too tedious to even bother with.
And this brings us to the most important file of all, program.md. This is where the human actually lives. And it's not code. It's just a plain English document where you, the director, write out the strategy. You tell the agent how to run the loop, how to understand the results, and crucially, how to use tools like get reset to safely just undo any changes that don't work out.
So you've got this elegant contract in place. What does that actually get you? Well, this is where the system's really smart constraints lead to some incredible power and efficiency.
The first key constraint is time. Every single experiment, no matter what the AI changes, runs for exactly 5 minutes. Now, this is such a critical design choice because it makes every result directly comparable. You're not just finding a better model, you're finding the best possible model you can train in precisely 5 minutes.
And if each experiment takes 5 minutes, well, you can run about 12 of them in an hour. So you just let the system run while you sleep, and you wake up to the results of nearly 100 methodical, disciplined experiments.
And the price tag for this night of relentless research? About $25. Just think about that for a second. That is a tiny fraction of what a single human researcher's time costs. This is what makes the Karpathy Loop so revolutionary. It's democratizing research, making it accessible to pretty much anyone with a single GPU.
Now, you might be thinking, okay, this is really cool, but it's just for machine learning, right? Well, the core idea behind this loop is actually way more universal than that.
So, this is the key. The loop doesn't actually care what it's optimizing. All it needs is a score, a number that can go up or down. If you can define a consistent, measurable metric for what better means, you can apply this exact same pattern.
And this isn't just a theory. We're already seeing it happen in the wild. Shopify's CEO used this exact pattern to optimize their liquid templating engine.
You have marketing teams using it to test landing pages and fine-tune their prompts. It just proves that whether your score is latency, or click-through rate, or code test coverage, the principle is the same.
And this brings us right back to that fundamental shift we talked about at the beginning. The Karpathy Loop is more than just a clever script. It's a blueprint for a whole new way of working. It suggests a future where our main value isn't in the execution, but in our ability to define a problem, set the rules, and then build the automated systems that tirelessly search for a solution. So the question isn't just what this means for research, it's what could it mean for your work?